Okay, so this is number 31 on the Benchmark 4 review packet. I see multiplication here. And think of your t as an x. I'm doing the derivative with respect to t here. If you want to change them to x, that's okay. So I'm going to do the derivative. So y prime equals, I see multiplication, I see variable expressions to both sides. You have to use the product rule. So you take the first expression, which is t, times the derivative of the second expression, which I'm going to look up that formula on my formula sheet. Inverse secant of u, the formula is 1 over the absolute value of u, in this case it would be absolute value of t, times the square root of u squared minus 1, so it would be t squared minus 1, and then times the derivative of u, which would be the derivative of t, which would just be 1. Plus, then you copy down your second function, sec inverse secant of t, times the derivative of t, which is 1. So that's your product rule on the stuff in the box. Minus, then you copy down your constant of a half. The derivative of natural log of t would be 1 over t times the derivative of t, which would just be 1. And then as far as simplifying, a note I probably should have had down for you, I probably should have had off to the side here that t is greater than 0. How do I know by looking at it? If I didn't have that note, how would you know t has to be greater than 0? Well, but even just looking at the original problem, what types of numbers can you take the natural log of? Only positive, yeah. So t has to be positive, because otherwise, take the natural log of a negative or 0, you get undefined. So because of that, I know that t has to be greater than 0, which means absolute values would have no effect on t. If it's a positive number, you could get rid of these absolute values. Here we're multiplying by t, here we're dividing by t, so you should cancel these out here. Alright, let's see what I have for an answer now for this one, for 31 on my answer key. And sometimes there's other correct answers that may not look exactly like what's on my key. So this comes out to, basically what I have left is my answer. Y prime equals 1 over the square root of t squared minus 1 plus inverse secant t minus, and over here I just took 1 times 1 and 2 times t, so I got 1 over 2t. That's what you'll see on my answer key. Next up, I'm going to do 32. These next two are a little quicker problems. 32, y equals x times e to the negative x. So what rule am I going to have to use there? Product rule again, yeah, because I got multiplication right there. So my first expression is x, so I'm going to go y prime equals x times the derivative of e to the x. Well, the derivative of e, or e to the negative x. Derivative of e to the negative x would be e to the negative x times the derivative of negative x, which would be times negative 1. Plus, then you copy down your second expression, e to the negative x, times your derivative of x, which is 1. So there's your answer. If you had that, you'd get full credit there. What I've done to simplify it on the answer key is factor out of this term and this term. These are separated in 2 terms by this addition sign. I factored out e to the negative x. And what that leaves me left with is x times negative 1, which is negative x, plus, that's what I have on my answer key. But really, either one of these would be correct on the test, as long as you have it worked out correctly, even if it's not simplified as far. There's really maybe no way to know how far I want to simplify it, unless it's a multiple choice question. Then, of course, you have to get it to match one of the answers. Number 33. Y equals e to the 1 plus natural log of x. Now, the simplest way to do this one is to break this apart. Before I do the derivative, break it apart and call this e to the first and e to the natural log of x. Now, remember this. If you multiply, remember this from algebra, if you multiply, what do you do with the exponents? You add them. So if the exponents are added and you want to split it and put an e under both of them, you have to use multiplication here. kind of doing the opposite of what you would have learned like in Algebra 1. Algebra 1, you say, okay, if we're multiplying, we add the exponents. In calculus, you're saying if the exponents are added, we can write down the base twice, e twice, and pull a multiplication here. Now, one more step. So e to the first is e. This is e and natural log are inverses of each other. E to the natural log of x. Anyone know what that equals? No, that just equals x. Okay? Let me just show you this real quick. The natural log of e to the x equals x, and e to the natural log of x equals x. Because the reason that is because e to the x and natural log are they're inverses, they undo each other. So the natural log kind of cancels out the e and you end up with just x. Same thing here, you end up with just x. So this is equal to x. So my derivative, now I'm finally going to do my derivative. Like the derivative of 3x is 3. The derivative of 2x is 2. So the derivative of ex would be what? E. Yeah, just e. It's kind of tricky. That's the simplest and shortest way to do that. Use some algebra rules to simplify, then do your derivative. Hopefully you're seeing a pattern that a lot of times it's easier to simplify the expression first before you do the derivative.